Swadhin Behera is an oceanographer. He was trained in India and started his career there before moving to Japan, where he now works for GEMSTAC, the institute that works, among other things, on the prediction of weather patterns. Welcome to Earth X, Swadhin.
Thank you.
Good to have you here. Now, weather patterns are, of course, very important these days, and a science that is maybe at a very early stage. What do we know about the weather?
So weather science is not new because people already knew about weather 200 years ago, maybe before that. But we started observing them only recently, especially taking periodical temperature and rainfall and precipitation and the pressure data all over the globe. We started maybe 50 years ago regularly, and then the satellite came in, which started giving a lot of information. Before satellites, when a cyclone comes in, a hurricane comes in, people didn't know where it is and when it is going to landfall and where it is going to landfall. And satellite gave that information. Okay, it has started forming here, taking this track, and using our traditional knowledge about how the weather pattern moves, we can say, okay, hurricane is going to landfall here, and then the track will be like this, and the intensity will be like this. And that saved a lot of lives. So
yes.
before cyclones, if I remember, like in India, like several 100,000 people used to die. But nowadays, not so many people die because they have early warning systems based on satellite data and also the weather modeling.
And now, of course, you're interested in developing further and further. What do you try to figure out that you don't know now and you think you will be able to know?
Excellent question. So the issue is, okay, we have advanced computers, advanced modeling systems now. We can predict what is going to happen in next 2 to 3 days. Beyond 3 days, from 3 days to several weeks, we are still struggling to give accurate predictions which can be reliable for practical uses. Mm-hmm. And that is where I think a lot of research is going on now, how to extend the skill of predictions beyond 3 days.
So if you go back, when you started your career, probably you couldn't even do 3 days, or not?
Yeah, that's true. So when we started our career, my career at least, at that time we didn't have even computer models in India. Of course, it was there in Europe and the US and Japan, and they are able to predict like 1 or 2 days ahead.
Okay, so we have kind of doubled.
Yeah, now we have doubled it, and we are going towards 1 week scale now.
Mm-hmm. Well, in my iPhone, I can see 10 days.
10 days, yeah.
But
yeah,
is that,
yeah.
that's not reliable?
Beyond 1 week, I will say may not be reliable always, but sometime may be okay.
Yeah, okay, but that's luck then.
Yes.
Yeah. So you think that really 3 days is
the real limit? Yeah. Yes. The ECMWF is pushing that to like 6 days, and even NCEP and other centers. Those who are based in mid-latitude areas where the frontal system move, they're kind of lucky to predict on longer time scales. Mm-hmm. But like India, where you have the tropical systems, the systems are more chaotic and they don't move organized way, so the skill of prediction for longer term is not so good.
So you mentioned India a few times. Of course, you are from India.
Yeah.
That is a country where they say that the monsoon, the annual rains, functions as the Minister of Finance. So in other words, these rains are of critical importance.
Yeah.
Your research is very important for India.
Yeah.
Why are you in Japan?
Excellent question again. So when I started my career, I was interested in modeling. And at that time, especially ocean modeling, at that time, we didn't have expertise in India. And the second thing, we didn't have enough good computers to run our models. And Japan was coming up with a new computer, which was fastest in 2002. I joined GEMSTAC in 1998. So 4 years after that, they had this computer, which was the fastest in the world, basically dedicated for weather and climate predictions. And that's why I thought, okay, this is the place where I should be to run my models and develop my models. because of the computer and infrastructure.
And once you're there, you're there. That's the way
yeah,
that works.
Yeah.
Well, let me ask you, of course, everybody talks about artificial intelligence, AI, these days. How is that going to help or not help your research?
Yeah, AI is kind of, it is going to help, no doubt about that. But the AI is based on data. And I believe we have a good amount of data for weather, not for climate. And for ocean also.
We are all lay people when we listen to you.
What
is, help me understand the difference between weather data and climate data.
Climate data, excellent question again. So weather is kind of activities, the pattern of atmospheric activities on scales of like from few hours to several days.
Okay.
That's the scale of weather. And we know, for example, the frontal systems, which move from west to east, and they bring rain or dry conditions. If you are in the cold front, you have the rain, and then the dry follows that. And those kind of things propagate from west to east, and we know how they propagate and their speed and where they're going. That's why the weather systems are kind of predictable, especially for mid-latitudes. But when you go to the climate, those are of the scale of like from a few months to several years ahead. And those scales of processes are different from weather processes. They're a combination of a lot of weather events, but at the same time, there are large-scale phenomena. Maybe you have heard the name of El Nino. When the eastern tropical Pacific gets warmer than normal. And it doesn't happen every year. It happens sometime in 2 years, sometime in 5 years, sometime in 7 years. And when El Nino happens, the warming in the eastern Pacific leads to more rainfall coming from the Indonesian regions towards central Pacific. That changes a lot of things through chain reactions, what we call atmospheric teleconnections. So they're connected to different things, how the weather changes, how the extreme event changes. And the driver is this kind of climate phenomena, which has a scale of like few months to several years.
So you say AI needs data, and we just don't have enough data yet.
Yes.
So how do you get more data?
So one way is continue to observe and allow AI to train themselves as we add more and more data. The second way is most of the data which we don't have on climate scales. On weather scale, we don't need so much of oceanic data. But when you go to climate scale, because El Nino and those kind of climate phenomena, they depend on ocean temperature. Not only surface temperature, but also subsurface temperature and the drivers. And those kind of data, for the surface temperature, we have the satellites to take the observations. For the subsurface, we don't have so much of monitoring systems. We have floats, which have started like from 2000. We have about 4,000 floats all around the global oceans. Those are called Argo floats. They drops down by themselves to like 1,500 meter or 2,000 meter, take the observations and come back, and then release the data through the satellite. And they do that every 10 days. So we have a kind of fair amount of data for the subsurface, but still not enough. One is not enough. One is we don't have data beyond 2,000 meter.
And if you were to have more of those data, you would be able to tell your forecasting, of course, can be better.
It can be better, yes. On both quantity and quality, like we can improve the quality of the predictions. Also, we can improve the extent of the prediction, like from 2 years, we can go to 5 years or 10 years.
How important is that when we try to create a more sustainable world?
So when you're going for a sustainable world, you know that we are in a world with temperature rising. We are in global warming world now. And in a global warming world, the weather systems might be getting more intense. We might have prolonged heat waves, intense heat waves, floods, droughts. And those kind of things are invariably related to what is happening with the climate. They are kind of embedded to each other. So if you can improve the climate observations and the predictions, in some way we can also improve our skills to predict extreme events sufficiently ahead of time so that we can take actions. At the same time, we can also develop adaptation strategies based on these kind of modeling efforts. Okay, models tells us that in 10 years we'll have more intense rainfalls, more intense heat waves. Then we need to adapt. We need to change policy. And that kind of things can be driven by this kind of monitoring.
So mostly it's helping adaptation.
Yeah, adaptation, yes.
Of course. So, and what is it that as you learn so much from the data you're studying, what does it tell you about what humanity needs to do to basically create a healthy future for everybody?
Yeah. So from the data and from our understanding, what we know that we have been doing a lot of damages to our environment, both in terms of greenhouse gases, which is of course related to global warming. Mm-hmm. Not the only factor, but it is mostly related to the global warming. At the same time, we are also polluting a lot our oceans. And that is causing a lot of unhealthy conditions for ecosystem, both for the marine ecosystem, also the human beings. Like we have some kind of bacteria, they thrive when the temperature goes up. We have E. coli, we have rotavirus, and several others. And those harmful bacteria and algae, they will cause more damage to our health and also our food, like the fishery and marine products. So in that sense, we need to both improve in terms of greenhouse gases and also the pollutions we are making. The plastic is another problem. Mm-hmm. Marine plastic is everywhere now, so that's another problem.
You know so much about the ocean. Do you still swim in the ocean?
Yes, yes.
You do?
Yes. But in India, I'll be careful.
Yes? Well.
The quality of water is decreasing. In Japan, it's still okay.
Yes.
Yeah.
What do you hope to have achieved, say, 5 years from now? What is your goal?
So you mentioned about the AI, and AI is evolving now. So our idea is like we are doing ocean modeling, we are observing, we have a lot of data, not so much, but we have some data now. We have the models. Now, how we utilize them to bring a product that can be used by anybody, not necessarily a researcher like me who knows the science, who knows the mathematics, and who knows the dynamics, but people, even general public, who is interested to know what is going to happen to their part of the ocean in the next 5 to 10 years. They will be able to use this kind of what we call digital twins, the digital interface. They can go directly like ChatGPT and ask, okay, what I should expect in 5 years from this area, the nitrogen level, the oxygen level, the fishery level, and those kind of things. And that is the kind of dream I have now, and we are developing that already to have this kind of digital twins and digital interface for everybody.
And give me an example of everybody. So who are you thinking of who could use that? Is that a fisherman or
even for recreation who are going for swimming, as you said, and they want to know the quality of the water.
Yes.
And what kind of flora or fauna they can expect if you're diving. And the second thing is fishermen, because we need sustainable fishery. We need to know the kind of stocks available there and how much they can explore, how much they can exploit, and how to sustain that, those kind of activities.
Yes, these data can be very important.
Yes.
Because indeed, if you talk about the stock of fish, of course,
you
would be able to say, well, there's halibut there, but don't fish more than that.
More than that, it's both ways not sustainable. Overfishing and underfishing.
Yes. I see what you're trying to do.
Yeah.
Well, that's wonderful work. What is the best news you've had in recent months?
The best news I would say we have a lot of activities going towards, especially in Europe, and to some extent in China and Japan, I think, also in US. People are more concerned about the state of our planet, and they want to do something. And that's one of the positive thing, the positive attitude in the society. That is helpful for us to kind of plan in the next 10 to 15 years what we are going to do together.
When you were growing up in India, you at one point decided you wanted to study the oceans. How did that happen?
Yes, so my interest in India actually, because when I was a kid, I was kind of scared by cyclones and also tornadoes. In India, we also have tornadoes.
Yes.
And I was interested to study them. So my original thought was to study weather patterns. Then I realized, okay, these are somewhere or other linked to oceans. The sea surface temperature and the subsurface temperature. And not many people were studying oceans in India at that time when I started modeling oceans in India. So I thought, okay, this is a good area for me. Not many competitions, and there is a reason why I'm doing it.
Yes.
So that's how I started.
Thank you so much, Swadhin.
My pleasure. Nice talking to you.